This film is about the interplay of factors that shape individual human brains over a lifetime. Hello, my name is Helen Neville, and for many years now we've been studying the development of the human brain. And we're particularly interested in the role of experience or input from the environment, which is also referred to as nurture, in shaping the development of our brains. We know that there's not a dichotomy between nurture on the one hand and inborn characteristics or nature on the other hand. There's a complex interplay between nature and nurture that determine every aspect of the development of our brains and all the functions that our brains support. What do we know about this newborn's brain? He reacts to being aspirated, for instance, and can see faces directly in front of him. Over the course of the next few months, the neurons in his visual system will make trillions of connections as he pays attention to the world around him. In early childhood, the number of connections between neurons rises very rapidly. In terms of the nuts and bolts or hardware, the brain doesn't look mature in terms of the size of the neurons, the density of neurons, and connections between neurons for at least 20 to 25 years after birth. As the brain develops over childhood and adolescence, it becomes increasingly specialized. We use a cap like this one that places little pieces of silver on the scalp. Event-related brain potentials, or ERPs, are voltage fluctuations in the EEG in response to a controlled stimulus. They reveal the time course of activation of a particular set of neurons within milliseconds. The giant magnets in this machine track the changes of blood flow in the brain, thus giving fine spatial resolution images of the brain, images of where particular neurons are active and what connections exist. When we tested motion perception and peripheral vision, we found that the people who were deaf from birth had a better ability to perceive objects in the far periphery of their vision than did the hearing people. Knowing that there are sensitive periods for many aspects of language and cognition, we decided to develop an intervention program. So for the past year and a half now, we've been working with children who go to Head Start preschools who are 3 to 5 years of age. We had to know about their spoken language abilities, knowledge base, and brain organization before our intervention.
They are eating at their table.
By 3 years of age, the brain's reactions to the two types of errors are already different: bilateral and posterior for semantic errors, and anterior and left lateralized for grammar.
Then he pushed the up and over button on his brand new power.
This child has been asked to pay attention to only one of the stories that is being read at the same time. We randomly assigned each child into one of 6 groups. For one group, their parents participated in parenting classes. 3 other groups had 8 weeks of 40-minute small group special sessions consisting of only 5 children with our teacher. After the interventions, we assessed the children again, and what we have found so far, these are still preliminary results, is that in 8 short weeks we improved many of the abilities of these children with our interventions.
Is walking. Yeah.